far away is Jupiter?
So Jupiter's about 5 times further from the sun than we are, so tonight it's about 46 light minutes away. And year after year it moves about 1 constellation through the sky as it orbits around the sun. So once you're familiar with the sky, it's not at all hard to find the planets because you'll remember where they were last year and the year before.
Today we're going to visit a Charlottesville gem for astronomy lovers. Housing what used to be the largest telescope in the U.S., this UVA facility is an excellent destination for anyone interested in taking a peek at how scientists used to measure the distance to nearby stars. Join us as we visit McCormick Observatory. Come on.
A little bit about the telescope that you're going to look through tonight. The telescope was the gift of Leander McCormick, who is the brother of Cyrus McCormick. It was a very big deal when this telescope came to Charlottesville, and Ormond Stone began a research program here looking at comets, measuring their orbits, measuring the moons of Mars, and also looking at nebula. The primary thing that McCormick Observatory is famous for starts with our second director, Samuel Alfred Mitchell, in 1914, began a program here to measure the distances to nearby stars. At the speeds we can travel right now, getting to the nearest star is a 75,000-year journey.
Ed, what is your role here at the observatory?
So I'm the director of the education and public outreach program that we have in the astronomy department.
And so UVA no longer uses this for its research, right?
That's right. So we no longer use McCormick Observatory for research for a couple of reasons. It's a small telescope by modern standards. There's a lot of light pollution from Charlottesville City, Albemarle County, and the university itself. The telescope wasn't really designed to hold the modern digital research cameras that are very big and very heavy. And the weather here in Charlottesville just isn't very good. We don't get nearly as many clear nights as we do at the major observatories in the desert Southwest.
Yeah, and so the astronomy department is still running full speed ahead and using all high-tech gear and equipment, and now this space is open to the public.
That's right. We have access to observatories in Arizona and New Mexico, and even access to observatories down in Chile for doing our research. And so now we make McCormick Observatory available for education purposes and outreach purposes.
So when is it open?
McCormick Observatory is open to the public on the first and third Fridays of every month, year-round. We're also open to educational groups on the second and fourth Fridays of every month, and they have to call the astronomy department to make advance reservations.
But the general public, for the Fridays, you just show up.
That's right. If it's a clear night between 9 and 11 p.m., you can just show up at any time, no prior reservations, no tickets required, and then you can look through the telescopes. And if it's a cloudy night, we have other programs that go on cloudy evenings.
So today I'll be talking about the structure of the universe. The universe starts from Big Bang, it's a big explosion, and then for many elementary particles. After about 100 million light years, the first star is formed.
So it takes a little time to prepare the space, the dome, for guests, right? Walk us through, what do you do?
So on a typical night, when it comes time to open up the observatory, the first thing that I'll do when I come in is open up the 3 doors that are in the dome here. It's a bit of an unusual design. Instead of 1 large door, we have 3 smaller ones, but we open up all 3 doors to equalize the temperature inside and outside the dome.
Why is that so important?
So if you've ever looked at over a parking lot on a hot summer day and you've seen the heat rising off the parking lot, you notice that everything behind it is shimmering and moving around and waving. And that's because the hot air is less dense than the cooler air and it bends light less. The same thing happens here at the observatory. If we were to heat the inside of the dome in the wintertime, when we open these doors, as the heat rushed out in front of the telescope, it would cause all the stars to look blurry and distorted. So we have to keep the inside of the dome the same temperature as the outside of the dome.
Right, okay. So you have the windows open, and then what else has to be set up?
The primary thing after that is to bring the telescope down to the ground to get that ready. And as we bring the telescope down, we'll put an eyepiece in the bottom. An eyepiece is what allows people to actually look through the telescope and see objects.
Is that what you used?
That's right.
Will you show me how you would bring it down?
Sure, to bring the telescope down. Today, back in 1885, the telescope was operated with ropes and pulleys. In the 1960s, they added electric motors to it. And so today we can just bring the telescope down with a motor.
Oh, that's great.
And even though we bring the telescope down with motors, when we're pointing the telescope, we still do it by hand. Even though the telescope weighs a few thousand pounds, you can grab the telescope and you can still move it, and we still point it by hand, just by grabbing it and moving it.
And sometimes you have it positioned so that guests actually have to stand on ladders, these ladders to peek through.
That's right. Depending on the object that we're looking at, if we're looking at an object that's very low in the sky, then the back end of the telescope is very high off the ground. So we have a small ladder and a much larger ladder that guests might have to climb all the way up to get a good view through the telescope. This telescope had just been finished at the factory in Cambridge, Massachusetts, when word came that its twin telescope at the U.S. Naval Observatory had discovered the 2 moons of Mars, and they were able to use this telescope before it even left Cambridge to confirm the discovery of the 2 moons of Mars. Now hang on for just a second. I'm going to rotate around and use that dome slit instead of this one because the telescope's staring at the inside of the dome there.
How did they use the telescope back then, and how did they measure the distances to nearby stars?
Astronomers measure the distances to nearby stars in the same way that you and I measure distances to things. We have binocular vision, 2 eyes on the front of our heads, because when I look at my finger with my right eye, I see it against one background, and with my left eye, I see it against another background. And if I blink my eyes, my finger appears to jump back and forth, not because my finger's moving, but because I'm seeing it from 2 different perspectives.
Right.
And that's how you and I judge distances to things. In astronomy, we do it by taking advantage of the fact that the Earth is orbiting around the sun. When the Earth is on one side of the sun and we look at a nearby star, it's against that background. But 6 months later, when the Earth is over here and we look at the same star, it seems to have shifted in the sky. Not because the star has shifted, but because the Earth has shifted over. And the size of that shift allows us to measure the distance to the star. But it's also moving through the sky because all the stars are orbiting around the Milky Way galaxy. So typically what you do is you would take 5 to 10 photographs of it now, and then 6 months later you would do 5 to 10 more, and then 6 months after that do it again, and 6 months after that. And for many, many years, every 6 months you'd be photographing the star multiple times. You would end up with hundreds of photographs of the star that now have to be carefully measured.
And the photographs are actually glass plates.
That's right. So the photographs that we took here at McCormick Observatory are 5 by 7 inch glass plates. The reason we use glass is, first of all, the program began in 1914 when there was only glass plates. But in addition, glass is dimensionally stable. That is, if we take an image of the stars and we measure it now, or we measure it 20 years from now, we should get the same results. When plastic film came out, astronomers did not adopt plastic film very often because plastic film can bend and twist.
Right.
And 20 years from now, if you took a photograph of the stars and the stars appeared to move, you would wonder, are the stars moving or is it the photograph that's bending and twisting?
How many plates do you have in storage here?
So over the years from 1914 till the parallax program ended, we gathered a total of about 144,000 plates here at McCormick Observatory.
And so what do you do with those now?
So the plates now are in storage in case anyone needs to use them. They're stored here at McCormick Observatory, and we're working very hard to preserve them for future generations.
Right.
I think a really interesting thing about these plates is this, for example, is a picture of a nearby star taken in 1969. We'll never be able to go back and photograph that part of the sky in 1969 again. We can
Right.
photograph it today, but that might be the only record we have of that part of the sky in that year. To give you an idea of how much of the universe we've explored, the closest star other than our sun is called Alpha Centauri, and Alpha Centauri in light travel time is 4.4 light years away. It's 4.4 years travel time.
Don't you have the largest collection of machines that measuring machines?
We think we have one of the largest collections of measuring engines in the country, starting with the earliest ones that we got here in the early part of the 20th century. And then every decade or so, the astronomers would upgrade to a better machine as the technology got better. And fortunately, here at McCormick Observatory, they didn't throw anything away. So we have all of the old machines in addition to the modern one.
And you even have a desk area that remains completely untouched. It looks exactly as it did in '94.
That's right.
When the program ended.
Yeah.
And nothing has moved.
And so when the parallax program was going on here, we would have astronomers or typically graduate students in the later years coming up and taking many photographic plates every night, night after night, every time the sky was clear. And then we had an astronomer down in the astronomy department who managed that program, determined which stars would go, the students would observe that night. Then when the plates would come in, the plates had to be developed. They then had to be graded as to whether they were good or bad, whether they could be used for science or not. And that whole desk where they did all of that sorting and grading still sits as it was in 1994.
You also have another building, a small building right beside the observatory, and you have 2 additional telescopes. Tell me about that.
So we call it the Student Observatory or the Doghouse because it looks like Snoopy's doghouse with a roof that rolls off. And that's both used in training our students, and it's open on public nights. In there we have a 14-inch modern computer-controlled telescope, and we also have an antique 6-inch telescope that was gifted to the university in the early 20th century. So on a clear night, you have the opportunity to look through the big telescope, and then you also have the opportunity to look through the 2 smaller telescopes and see a presentation, usually by a faculty member.
And then you have museum spaces. You have 2 museum spaces. Talk about those.
So we have a museum space that talks a little bit about the history of the observatory. It has some artifacts from the early years, and it has some artifacts from the McCormick family who donated the telescope to the university. And then we also have 2 other areas with light boxes that highlight research that's going on in the department today. So right now, for example, we have a Saturn exhibit up because one of our scientists, Ann Verbisher, is working on the Cassini mission to Saturn. She's one of the principal scientists working on that mission, and she got us a number of images that were taken by Cassini in orbit around Saturn.
And there is one other thing that goes on here. You have a weather station, and it's one of the only weather stations in Virginia, I think, where the weather is checked every day.
That's right. So we have a National Weather Service weather station here, and it's the oldest, I believe it's the oldest continually operated weather station in Virginia. We have weather records going back to the 1880s, and they've been measured here every day. We have someone that lives in a house up here next to the observatory, and every morning at 8 o'clock, he comes over to the weather station and manually reads the 2 measurements in there, the high and the low for the day before, and also checks the rain gauge. And you will often hear on the local news that a new record was set in Charlottesville, and that record is usually taken here at McCormick Observatory.
It's fantastic. Well, Ed, thank you so much.
Okay, if I can have everyone's attention for a second. Jupiter is getting lower and lower on us, so the bad news is we're not going to look at Jupiter. The good news is Saturn's getting higher and higher, so I'm going to switch over to Saturn. But what that means is I'm going to bring the telescope down and up, and I have to bring that big chair over. So everybody in the dome stand over there in the empty space for a few minutes, and then I'm going to move the telescope as well.